In this video, we're going to look at L'Hopital's rule. This is the last lesson before your unit test and the last lesson for this unit. And L'Hopital's rule is an application of derivatives, and we're going to use this to help us determine the limit of indeterminate forms. More specifically, the limit of f of x over g of x, so function over function. If this becomes an indeterminate form, then we can find the limit by taking the derivative of the numerator and the derivative of the denominator as well. And this limit is going to yield the same limit as f of x over g of x. So the first thing you're going to do, in order to even use the L'Hopital's rule, you have to show that this limit tends towards 0 over 0 or infinity over infinity as an indeterminate form. So let's take a look at this first example. The first thing we're going to do is show that it's tending towards 0 over 0, infinity over infinity. And I'm going to use arrows to do this. I don't want to say it's going to be equal to, because it wouldn't make sense if it's equal to 0 over 0. We can't say it's equal to an indeterminate form, but we can say it's tending towards it. So if I were to evaluate this, or try to, then we would get e to the 3 times 0 minus 1 over 0, and then this would tend towards 0 over 0 overall. So I've shown that our limit is tending towards 0 over 0, so we can use the L'Hopital's rule now. So this means I'm going to take the derivative of the numerator and then take the derivative of the denominator. So in your numerator, e to the 3x, we're going to have to use chain rule here to do that. So the derivative of e to the x is e to the x. If it has a 3x in there, that's fine. We'll just leave it there. I just need to multiply by the derivative of 3x, which is just 3. The derivative of 1 is 0. The derivative of x is 1. Now we can just evaluate this limit because it's not going to give us indeterminate form anymore. So that's 3 times e to 3 times 0. This is 3 times 1, so your overall answer is 3. In the next example, we're going to show that's an indeterminate form. So if we try to evaluate this, this is going to give us 0 over 0. So again, we need to show that it's indeterminate form. So now we're going to use L'Hopital's rule. I'll take the derivative of the numerator. Remember, this can be rewritten as 1 plus x to the power of a half. So if you were to differentiate that, you would get 1/2 times 1 plus x to the power of negative a half. Derivative of negative 1 is just 0. Derivative of x is just 1. I'm just going to rewrite this a bit before we evaluate. So this is equivalent to what we just had, and then now we can try to evaluate because it won't give us indeterminate form. So your answer should be 1 over 2. Whenever you're using L'Hopital's rule, you should state it somewhere. So you could say that these two questions were used by L'Hopital's rule. We'll try 2 more, and then I want you to try some on your own. For C, again, we want to show it's an indeterminate form. So 10 of 0 is 0, and then 5 times 0 is 0, so we still get 0 over 0. We'll take the derivative of the numerator, which is 2 secant squared x. Then we'll take the derivative of the denominator, which is 5. We're not going to get an indeterminate form if we were to evaluate this, so we can go ahead. Instead of writing secant, I'm going to change this to cos. So equivalently, this is cos squared of 0 over 5. Cos of 0 is 1, so 1 squared is 1. Final answer is 2 over 5 for that one. For D, it's a little bit different. You can use L'Hopital's rule more than once, as long as it's in indeterminate form. So for this one, if we look to see if it is in indeterminate form first, ln of infinity is a large number. 2 times the root of a large number is still a large number. So we do have indeterminate form here. We're going to use L'Hopital's rule. So once you take the derivative of the numerator, ln x becomes 1 over x. Derivative of this becomes 2 over root of x. We can simplify this a bit. So I'm going to change this to multiplication and flip the second fraction. So if we check to see what happens here, the root of infinity over infinity kind of tends towards infinity over infinity again. So that means we can use L'Hopital's rule again. So our numerator is the root of x, which in other words, that's 1/2 x to the negative a half. Then our denominator is 2x, derivative of 2x is 2. Now let's simplify this and see what we get. So equivalently, this is 1 over 4 root x. 1 over 4 root x, and if we evaluate this as x approaches infinity, we're going to get 1 over a really, really large number. That's 0. Okay, so we use L'Hopital's rule twice here. I'm just going to write this on the side. So using the same sort of principles, I want you to try the next 2 questions in example 4, and then press play for the solution. All right, so for A and B, the first step you're going to use is to find or make sure that this limit is tending towards an indeterminate form. So the first one is going to be infinity over infinity. Then you're going to take the derivative of the numerator, take the derivative of the denominator, and you're going to get another indeterminate form. So if you look at the second part, when we have 2x over negative e to the negative x, we try to evaluate this. We're still going to get indeterminate form, so we're going to use it again. And then we'll take the derivative of 2x and negative e to the negative x. We get 2 over e to the negative x, and try to evaluate that. That's 2 over a large number, and that's 0. In B, show that we're going to get 0 over 0 if we try to evaluate the limit, and then we'll differentiate the numerator and then differentiate the denominator. We're going to have to do it twice because we're still going to get indeterminate form. So I'm showing that there. This is still 0 over 0, so we do it again. Use L'Hopital's rule again, rearrange, and then evaluate that limit. So you should get negative 1 over 8. So for example 6, I'm just stating here that there are other indeterminate forms out there. You can still use L'Hopital's rule with these forms, but you don't have the differentiation tools to do that yet. We didn't cover logarithmic differentiation in this course, mainly because it's not part of the scope of this course. If you ever end up taking calculus again in university, they will teach you log differentiation. But for example 6, part A, we're going to use the same principles as before, but we want to change it to a fraction first. So why don't you try this question, try to rearrange your limit so that it's a fraction, and then evaluate the limit as usual. So for example 6a, we can rewrite e to the negative x root x as root x over e to the x. Remember that when you have a negative exponent, you can just write the reciprocal with a positive exponent. So the root of x over e to the x, this will tend towards infinity over infinity. Sorry. And that means we can use L'Hopital's rule. Sorry, this was, yeah, infinity over infinity. And then now we can use L'Hopital's rule. We'll evaluate root of the x, find the derivative of that, and then we'll find the derivative of e to the x. simplify, and then evaluate it. So 1 over a really large number is 0, so your final answer is 0. You will not do B just because you don't have the tools to do question B. So again, if you have a limit that's multiplying each other, if you can change it to a fraction, you can still use L'Hopital's rule as long as your limit is tending towards indeterminate form.